Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to begin our discussion on supervised classification. Right. And so if you remember back to our discussion on unsupervised classification, we said that unsupervised classification, you gave the computer an image, and it sort of grouped the pixels based on the inherent variation within the image. Supervised classification, on the other hand, takes in additional property that we call training data. So training data at its most basic level is a set of locations with labels. Right, so unlike unsupervised classification, right, with supervised classification, we're actually telling the computer, hey, computer, we want these classes, right? Maybe it's water, urban, and vegetation. Maybe it's farm fields, forest, and water, right? It doesn't have to be 3. It can be any number of classes, really. But the idea is that we're giving it information that allows it to sort of generate these what we would call trained algorithms, because the computer now knows what to look for based on what we've told it to look for. And we're going to spend several videos talking about this idea of training data. But what I want to do first is I want to go through some of the algorithms that and sort of at a high level explain how they actually go about separating out the different classes. But before that, I want to just sort of reiterate conceptually what a supervised classification is doing, so that hopefully you can see the difference between supervised and unsupervised. Okay. So what I've done is I've sort of pre-generated this graphic here. So I would encourage you to pause the video and make a copy of it, and then we're going to go through each of the parts so that you know what's going on. Okay, hopefully you took a second, paused the video, and copied this down. And now we're going to go through what's actually happening here. And again, this is a sort of conceptual diagram. So if you think back to our remote sensing data structure, right on the left right here, that's what this is. This is the remote sensing data structure. And in this case, we have 3 bands, a red band, a green band, and a blue band. And the goal right now is to figure out what class we want to assign this bottom right pixel here, right? So this pixel. Right, what do we want to assign it to? And in this case, right, we've generated training data, which again we'll talk about in more detail in a little bit. But we've generated training data based on urban, water, and forest. So the idea here is that the computer is going to generate for us, for all of the pixels that we have, either urban, water, or forest as a classification. Okay? So at the highest possible level, what it's going to happen is it's going to extract the values for this pixel. Right? Again, we're focusing on the lower right-hand pixel here. It's going to extract these pixel values. Right? That's what these are here. So this step right here, this is extraction. Right? It extracts the values. Okay. Then the next step right here is it's going to compare. Right? It's going to compare the pixel values, right, for each of the bands for a single pixel. It's going to compare those to the training data that we provided. Okay, so this is just a sample. I made this data up, right? So urban might have something that looks like this, water might have something that looks like this, and forest might have something that looks like this. And so at the highest level, right, what supervised classification is going to do is it's going to look at these pixel values. It's going to look at, in some way, shape, or form, it's going to compare them to the classes that we've given information for. Okay? And so if you look, right, 67, 57, and 21, right? If you compare these, it would make most sense, right, that it would be forest, right? Because 62, 55, and 20 is going to be closest to these three, okay? So what it's going to do is it's going to say, okay, I'm going to call this pixel forest. So if we look over here, when we classify, right, so we've extracted, we've compared, and we classify, you'll see that we have this green pixel. This is now green, which this would be forest. Right, we've classified the image from 3 bands containing red, green, and blue, either radiance or reflectance, again, depending on how much processing was done. We've run it through this algorithm where we extracted the values, we compared it to the training data, then we classified it. So now we have a single band where the value of the pixel is now meaning that this pixel is forest, okay? So hopefully that makes sense. And the thing that we're going to spend a lot of time talking about is this step right here. Right, and what we're going to do in this module is we're going to talk about how do we do the comparison, right? How do we compare, right? This is going to be the algorithms. And how do we get training data? Okay. So the rest of this module is going to deal with algorithms. We're going to sort of broadly look at 3 of the most widely used. And then how do we get the training data, right? What do we have to do? What sort of mindset do we need to have when we're figuring out how we're going to generate this side here so that when we do this comparison, we are feeling justified that we're making a valid comparison, okay? So hopefully that makes sense. And if you have any questions, please reach out. Thank you.